Yes, hi friends. Today let's discuss about the Dalton's law of partial pressures and the problems and the questions given on that. So it is a class 9 syllabus, the states of matter, exercise 3. So in the synopsis 3, the topic is Dalton's law of partial pressure. So the synopsis 3, the Dalton's law of partial pressure is discussed. In that there are two exercises, exercise 1 and exercise 2. In that is exercise 3. In exercise 3, stage 1 and stage 2. In the stage 1, exercise 3, stage 1, there are 20 questions. Yes, there are 20 questions given in the stage 1. In stage 2, single option correct type, then 7 questions are given. Then advanced level, 3 questions are given, 10. Then confrontation type, then there are 2 pairs given, then matrix matching. These are the exercises. The total number of and integer type questions, the total number of questions 20 in the stage 2 and the 20 in the stage 1. Okay. Before starting these exercises, let's discuss about the Dalton's law in brief. Okay. What is Dalton's law? The definition of Dalton's law is the total pressure of a gas mixture at constant temperature. Remember the condition. The total pressure of a gas mixture is equal to the sum of partial pressures of all the gases present in the mixture. I will repeat. The total pressure of a gas mixture at a constant temperature is equal to the sum of partial pressures of all the gases present in the mixture. So, the total pressure of a gas mixture is equal to the partial pressure of the first gas plus the partial pressure of the second gas and the partial pressure of the third gas and so on, the number of gases present in that mixture. So, the total pressure of the gas is equal to the sum of the partial pressures of all the gases present in the mixture. That is formula 1. And second one is the total pressure of a gas mixture is equal to total mole number of all the gases present in the mixture into RT by V. Friends, try to understand. It is nothing but PV is equal to nRT. It is nothing but PV is equal to nRT. P is equal to nRT by V. P is equal to nRT by V. So the total pressure of the gas mixture is equal to total number of moles of all the gases present in the mixture into RT by V, where R is the universal gas constant, T is the temperature in Kelvin unit, and V is the volume. So the total pressure is the sum of the partial pressure of all the gases, or otherwise the total pressure of gas mixture is equal to total number of moles of all the gases present in it into RT by V. Then the partial pressure of a gas is equal to the partial pressure of a gas present in the given mixture is equal to number of moles of that gas into RT by V. So the partial pressure of one gas present in a mixture is equal to the number of moles of that gas into RT by V. Observe, compare these two one, both are same, P is equal to 10 RT by V. Here also P is equal to 10 RT by V. If you take the total number of moles of all the gases present in the mixture, it gives the total pressure. If you take the number of moles of one gas present in the mixture, it gives the pressure of that gas, which is called as partial pressure. So, partial pressure of a gas in a gas mixture is equal to number of moles of that gas into RT by V. Or we have another formula. The partial pressure of a gas is equal to total pressure of the gas mixture, into mole fraction of that gas in the mixture. Mole fraction of that gas in the mixture. Mole fraction is denoted by X. Mole fraction. What is mole fraction? Mole fraction is equal to number of moles of that gas by total number of moles of all the gases present in the mixture. That is called mole fraction. So partial pressure of the gas is equal to total pressure of the gas into the mole fraction of that particular gas. What is mole fraction? Mole fraction of a gas is the ratio of the number of moles of that gas to the total number of moles of all gases. That's all. Only there are 4 formulae. There are 2 formulae to calculate the total pressure of a gas mixture, and there are 2 formulae which are useful to calculate the partial pressure of a gas mixture. That's all. So the total pressure of gas is equal to the sum of the partial pressures of all the gases present in the mixture. That's first one. Second one, the total pressure of the gas mixture is equal to total number of moles of all the gases present in the mixture into RT by V. That is the total pressure. And the second one, the partial pressure of a gas in a mixture is equal to number of moles of that gas present in the mixture into RT by V. Or if the total pressure of the gas mixture is known, then the partial pressure of one gas is equal to the total pressure of the gas mixture into the mole fraction of that gas. What is mole fraction? The mole fraction of a particular gas is equal to mole number of that gas present in the mixture by the total number of moles of all the gases. That's all. The entire Dalton's law depends only on these 4 formulae. Now let us do the exercises. As it is the exercise 3, stage 1. Read the first question. Equal volumes of, or equal masses, not volumes, equal masses of sulfur dioxide and oxygen are kept in a vessel at 27 degrees. The total pressure of the mixture is 2.1. Calculate the partial pressure of SO2. Read the question and understand the data. In a gas mixture there are 2 gases, sulfur dioxide and oxygen. The 2 gases are taken in equal masses and the temperature is 27 degrees centigrade, and the total pressure of the gas mixture is given. Calculate the partial pressure of SO2. Now, equal masses of sulfur dioxide and oxygen. Equal masses means, let us take that mass of sulfur dioxide is 1 or 1 gram, because equal masses. So the mass of oxygen is also 1 gram, because equal mass are taken. And the total pressure is given. The total pressure of the gas mixture is 2.1 atmospheres. Calculate the partial pressure of sulfur dioxide. You know that the partial pressure of a gas is equal to total pressure into mole fraction of that gas. So partial pressure of sulfur dioxide is equal to the total pressure of the gas mixture into mole fraction of sulfur dioxide. Mole fraction of sulfur dioxide means the number of moles of sulfur dioxide by total mole number. ante number of moles of sulfur dioxide plus number of moles of oxygen, where the total pressure is given. We can calculate the number of moles of sulfur dioxide and number of moles of oxygen because it was given that equal masses of sulfur dioxide and oxygen are taken. Therefore, if 1 gram of sulfur dioxide and oxygen are taken, then the number of moles of sulfur dioxide is equal to number of moles weight by molecular weight. The weight of sulfur dioxide is 1 and the molecular weight of sulfur dioxide is 64. So number of moles of sulfur dioxide are 1 by 64. Like that, the number of moles of oxygen. So weight of oxygen by molecular weight of oxygen. Here the weight of oxygen is taken as 1 gram and the molecular weight of oxygen is 32. Therefore, the partial pressure of sulfur dioxide is equal to the total pressure is given as 2.1 into the number of moles of sulfur dioxide, it's 1 by 64 by total mole number of sulfur dioxide and oxygen. The total mole number of sulfur dioxide plus oxygen is equal to 1 by 64 plus 1 by 32. That is equal to 3 by 64. 3 by 64. So the total mole number is 3 by 64. The partial pressure of sulfur dioxide is equal to total pressure 2.1 into number of moles of sulfur dioxide 1 by 64 by 3 by 64. Therefore, the numbers partial pressure of sulfur dioxide is equal to 2.1 into 1 by 3. That is equal to 0.7 atmospheres. 0.7 atmospheres. That is the partial pressure of sulfur dioxide. Here the total pressure is given. Calculate the partial pressure of sulfur dioxide. The partial pressure of sulfur dioxide is equal to total pressure of the gas mixture into mole fraction of sulfur dioxide. Mole fraction of sulfur dioxide is equal to mole number of sulfur dioxide by the total mole number of the sulfur dioxide plus oxygen. So total pressure is 2.1 into mole number of sulfur dioxide is 1 by 64 by the total mole number, the number of moles of sulfur dioxide plus number of moles of oxygen. Then the partial pressure of sulfur dioxide is 0.7. If the question is, now based on that, I want to extend this problem to further step. If the question is asked, what is the partial pressure of O2? Here the total pressure of the gas mixture is 2.1. In that the partial pressure of SO2 is 0.7. Therefore, what will be the partial pressure of oxygen? We know that the total pressure of a gas mixture is equal to sum of the partial pressures of all the gases present in the mixture. The total pressure is 2.1. Just now we calculate the partial pressure of SO2, that is 0.7. Therefore, the partial pressure of oxygen is equal to 2.1 minus 0.7. That's all. That's all. That is the first one. Then coming to the second problem. In a 10 liters vessel, the total pressure of gas mixture containing hydrogen, nitrogen, carbon dioxide is 9.8. Here try to understand the data. In a 10 liters vessel, there are 3 gases: hydrogen, nitrogen and carbon dioxide, and the total pressure is 9.8. If the partial pressure of hydrogen and nitrogen is 3.7 and 4.2 respectively, the partial pressure of CO2. It's very simple. The total pressure is 9.8. The partial pressure of hydrogen is 3.7. The partial pressure of nitrogen is 4.2. Therefore, the partial pressure of CO2. We know that the total pressure is equal to the partial pressure of hydrogen plus the partial pressure of nitrogen plus the partial pressure of, what is the third gas? What is the third gas? Hydrogen, nitrogen and carbon dioxide. Carbon dioxide. It was given that the total pressure of the gas mixture is 9.8 and the partial pressure of hydrogen is The partial pressure of hydrogen is 3.7, nitrogen is 4.2. Partial pressure of hydrogen is 3.7 and partial pressure of nitrogen is 4.2. Calculate the partial pressure of CO2. The total pressure is equal partial pressure of first gas plus partial pressure of second gas plus partial pressure of third gas. Here the total pressure is given and the partial pressure of hydrogen and nitrogen is given. Therefore, you can calculate the partial pressure of CO2. So the partial pressure of CO2 is equal to 9.8 minus 3.7 minus 4.2. That is 9.8 minus 7.9. That will be the answer. That is the second question. Then coming to the third one, 3 grams of hydrogen and 24 grams of oxygen are present in a gas mixture at constant temperature and pressure. The partial pressure of hydrogen is 3 grams of hydrogen and 24 grams of oxygen are present in a gas mixture at constant temperature and pressure. The partial pressure of hydrogen is, it's very simple. The answers 1/3 of the total pressure, 2/3 of the total pressure. 3 grams of hydrogen, 24 grams of oxygen. 3 grams of hydrogen and 24 grams of oxygen are taken in a vessel. Calculate the partial pressure of hydrogen. Here 3 grams of hydrogen means calculate the number of moles of hydrogen. Number of moles of hydrogen is equal to weight of hydrogen by the molecular weight of hydrogen. So weight of hydrogen is 3 and the molecular weight of hydrogen is 2. So number of moles of hydrogen is 1.5. Then like that, calculate the number of moles of oxygen. Number of moles of oxygen is equal to weight of oxygen by its molecular weight. That is 3/4. Then the total mole number of oxygen, not oxygen, hydrogen and oxygen. That's number of moles of hydrogen plus number of moles of oxygen. It is 1.5 plus it is 0.75. That is 2.25. Now the question is, the partial pressure of hydrogen is, the total pressure of hydrogen into mole number of hydrogen by total mole number of hydrogen plus oxygen. Here the total pressure is not given. So let us take that the total pressure is total pressure into mole number of hydrogen is 1.5 by total mole number of hydrogen plus oxygen 1.5 plus 0.75, that is 2.25. That is the partial pressure of hydrogen is equal to the total pressure into 15 by 22.5 or 7.5 2s are 7.5 3s are. Therefore partial pressure of hydrogen is equal to the total pressure into 2/3. So in that mixture the partial pressure of hydrogen is the 2/3 of the total pressure. So I want to extend the problem. In the question, what will be the partial pressure of oxygen? If the partial pressure of hydrogen is 2/3, the partial pressure of oxygen is 1 minus 2/3. That's equal to 1/3. Yes, check the answer. 3 grams of hydrogen, 2/3 of the total pressure. The second option is correct. Yes. Let's come to the fourth one. A mixture contains 4 grams of hydrogen, 42 grams of nitrogen. The fraction of the total pressure exerted by the nitrogen, the same model as the previous one. Here 3 grams of hydrogen, 24 grams of oxygen are taken in a gas mixture, the partial pressure of hydrogen. Here 4 grams of hydrogen and 42 grams of nitrogen are taken. The fraction of the total pressure of nitrogen, same 3/7, 4/2, 3/2, the same model. You can answer it easily. Then come to the fifth one. If 1000 milliliters of gas A at 600 torrs and 500 ml of gas B at 800 torrs are mixed in a 2 liter flask. What will be the total pressure of the gas mixture? It is somewhat different formula. Just I will explain. If two gases of different volumes and different pressures are mixed in a container, for example, V1 milliliters of a gas A at a pressure of P1 and V2 milliliters of another gas at a pressure of P2 are mixed together. Then the pressure of the gas mixture, the resultant pressure of the gas mixture is P1 V1 plus P2 V2 by the total volume of the gas mixture. It is the formula. Yes, please understand. If two different volumes of gases at different pressures are mixed in a container, then the total pressure of the gas mixture is P1 V1 plus P2 V2 by total volume. P1 is the pressure of the first gas and V1 is its volume. And V2 is the volume of second gas and its pressure is P2. And if the two are mixed in a vessel whose volume is V, then the total pressure of the gas mixture is P1 V1 plus P2 V2 by total volume. In our previous question, here 1000 milliliters of gas A at 600 torrs and 500 milliliters of a gas B at 800 torrs are mixed in 2 liters vessel. So P1 V1 plus P2 V2 by the total volume, that they are mixed in 2 liters volume, total volume. It gives answer. Therefore, here the first gas 1000 milliliters into 600 torrs P1 V1 plus P2 V2 500 milliliters of another gas at 800 torrs P2 V2 taken in 2 liters vessel. 2 liters vessel means 2000 ml. Therefore, the pressure of the gas mixture is equal 600 into 1000 plus 500 into 800 by 2000. That means 6 into 10 power 5 plus 4 into 10 power 5 by 2 into 10 cube, or 6 by 2 into 10 square, or that is 300. Not 300. 6 into 6 plus 4 into 10 by 5. Here that 6 plus 4 here 6 plus 4 into 10 power 5, 6 plus 4 into 10 power 5 by 2 into 10 power 3, that is equal to 10 into 10 power 5 by 2 into 10 power 3, that is equal to 5 into 10 square or 500 torrs. Ready? A question? Fifth one. 500 torrs is the answer. So again, the formula, if two gases of different volumes and different pressures are mixed, then the mixture of the pressure of the gas mixture is equal to P1 V1 plus P2 V2 by total volume. Or if more than two gases are mixed together, then P1 V1 plus P2 V2 plus P3 V3 plus P4 V4 so on Pn Vn by the total volume. That's all. As coming to the next one. Sixth one, in the gas mixture 1 gram of hydrogen, 5 grams of helium are mixed in a 5 liters vessel at 20 degrees. Calculate the total pressure. Very direct question. 1 gram of hydrogen, 5 grams of helium. So we can calculate the number of moles of hydrogen, number of moles of helium. Are mixed in a 5 liters vessel, volume is given. At 20 degrees centigrade, temperature is given. Calculate the total pressure of the mixture. We know that the total pressure of the gas mixture is equal to total number of moles of the gases present in the mixture into RT by V. Here, how many grams of hydrogen is given? 2 grams of hydrogen, not 2 grams. 1 gram of hydrogen, 5 grams of helium. 1 gram of hydrogen and 5 grams of helium. You can calculate the number of moles. Number of moles of hydrogen is equal weight of nitrogen by its molecular weight 2, and the number of moles of helium is equal weight of helium 5 grams by its molecular weight. So it is 0.5. It is it is 1.2. Is it 2? కాదు కదా 10 1.25. Then the total pressure is equal to total mole number 0.5 plus 1.25 1.75 into R 0.0821 into temperature is given as 20 degrees, 20 plus 273 Kelvin 293 by what is it, volume. How many liters of vessel is taken? Taken 5 liters vessel. 5 liters vessel means the volume is 5. Remember, the R value is taken in liter atmosphere per degree per mole. Therefore, volume must be expressed in the liters only, 5 liters. Calculate this one. It gives the total pressure. Just you have to calculate this one. So the answer may be, so calculate it, you will get the answer. As next one, the seventh one, in 1 liter flask at certain temperature, there are 2 grams of hydrogen, 8 grams of oxygen. The mole fraction of oxygen, here the mole fraction is given or asked, not the partial pressure or the total pressure. Just to calculate the mole fraction of oxygen in a given mixture of 2 grams of hydrogen and 8 grams of oxygen. What is mole fraction? What is mole fraction? Mole fraction of a gas is equal to mole fraction of a gas is equal to mole number of that gas by total mole number of all the gases present in the mixture. Here, in our problem, only 2 gases are there. That is 2 grams of hydrogen and 8 grams of oxygen. 2 grams of hydrogen and 8 grams of oxygen. The mole fraction of oxygen, calculate the mole fraction of oxygen. Mole fraction of oxygen is equal to mole number of oxygen by the total mole number. That means number of moles of oxygen and number of moles of hydrogen. So number of moles of hydrogen is equal to weight of hydrogen by the molecular weight of hydrogen, that's 1. And the mole number of oxygen is equal to 8 grams is given, 8 by 32, that is 1 by 4 or 0.25. Therefore, the mole fraction of oxygen is equal to mole number of oxygen 0.25 by the total mole number of hydrogen plus mole number of oxygen, that's 1.25. That is 25 by 125. 25 by 125. That is 1 by 5 or 0.2 is the answer. 0.2 is the answer. Then coming to the next one, a vessel contains methane and oxygen in the mass ratio of 2:1. In our first problem, equal mass of SO2 and O2 are taken. But in the 7th problem or 8th problem, a vessel contains methane and oxygen in the mass ratio of 2:1. The fraction of partial pressure of oxygen in the pressure. Here the methane and oxygen are taken in the 2:1 ratio, methane to oxygen 1. Methane and oxygen are taken in 2:1 mass ratio. Then the partial pressure of methane or partial pressure of oxygen we can calculate. First, take the number of moles of methane. Number of moles of methane is taken as 2 because the mass ratio. Because mass ratio, instead of mass you may take mass ratio because it is a relative or comparison. Therefore, the number of moles of methane is equal to 2/16 and the number of moles of oxygen is, the mass ratio is 1. So 1/32. Therefore, the partial pressure of methane is equal to total pressure into mole fraction of methane. Mole fraction of methane means mole number of methane by total mole number. The total mole number is equal to 2/16 ante 1/8 plus 1/32. That is equal to 5/32. Therefore, the partial pressure of methane is equal to total pressure into mole fraction of methane. Number of moles of methane is 1/8 by total mole number 5/32. Like that, calculate it, you will get the answer. Yes. Coming to the next one. Two identical vessels are filled with 44 grams of hydrogen and 44 grams of oxygen and equal masses. It's nothing but the first question. If the partial pressure of the CO2 is 2 atmosphere, the partial pressure of hydrogen is just 2 equal weights are taken. Calculate the number of moles of hydrogen and calculate the number of moles of oxygen. Because the partial pressure of one gas is given, you can calculate the partial pressure of another gas. Yes, in the 10th question, oxygen and helium are taken equal weights in the vessel. Again, equal weights are taken. Same question. The pressure exerted by helium in the mixture is the same question as the first question. That's all. These are the first 10 questions. In this exercise, there are 20 questions. Remaining 10 questions are in the same model. Try to answer it. If you get any doubt, send the question number through WhatsApp. Then I will send the answer, or again I will explain the remaining questions in this evening and upload another video by this evening. Okay, thank you.